Welcome to this explainer. Today, we're jumping right into the hidden millisecond by millisecond complexities of modern home energy systems. If you've ever stared at that heavy box mounted on your garage wall and wondered what's actually happening inside, well, you're in exactly the right place. We're going to tear it down and see how this whole thing really ticks.
Let's kick things off by busting the single most common and totally incorrect assumption people make about hybrid solar setups. Is a hybrid inverter literally just an off-grid inverter with a grid plug slapped on the side? Honestly, it's a pretty reasonable guess for anyone trying to wrap their head around their home system. But as we're about to see, the reality is way more complex than that. Okay, to really grasp the hybrid, we first have to look at the off-grid baseline. Think of it as a simple one-way street. Energy flows in one direction, from your solar panels straight to your battery, through the inverter, and finally into your home's loads. It's a completely isolated network. No connection to the utility grid whatsoever. The inverter here, it's basically just a toll booth on that one-way street, using some pretty simple logic to convert DC power into AC power.
And that is exactly why we've got to throw a giant red X through that myth. A hybrid inverter requires vastly more engineering to operate safely. It actually sits at the very center of your home's energy universe. It doesn't just pass power along down the line. It's actively measuring, analyzing, synchronizing, and managing highly dynamic energy flows across multiple different networks all at once.
So, to truly demystify this piece of hardware, we're going to tear down its operations into 5 distinct engineering functions: sources and flow, grid synchronization, anti-islanding safety, backup operations, and continuous intelligence. Section 1, Sources and Flow, or what I like to call the high-speed traffic cop. Unlike those basic off-grid systems we just looked at, a hybrid inverter has to constantly juggle 3 completely distinct energy sources at the exact same time: your solar PV array, your battery storage, and the massive utility grid. It might just use one of these to power your house, or it might blend them, say, combining solar and grid power, shifting continuously based on exactly what your house demands at any given second.
This is where the traffic cop analogy really shines. Because a hybrid operates in parallel with the main utility grid, power is actually flowing bidirectionally. It's pulling power into the house when you need that extra juice, but it's also safely exporting your surplus solar energy back out to the grid the moment your batteries hit 100%. It is constantly directing traffic.
Moving on to our second function, grid synchronization. Basically, a precision orchestra.
This is all about the invisible, hyper-precise task of matching the utility grid. By definition, grid synchronization is the absolute mandate to perfectly match the grid's exact voltage, frequency, and phase angle before the inverter even thinks about allowing parallel operation. The huge takeaway here? The inverter can't just generate power and blindly dump it onto the wires. It literally has to play its energy notes on the exact same beat as the massive public grid.
So what happens if it gets that beat wrong? Well, if those waveforms aren't perfectly aligned, meaning they're unsynchronized, you get a massive problem. Connecting out-of-sync AC sources produces destructive currents that could catastrophically damage your home's wiring, blow your protective devices, and completely fry the inverter itself. Off-grid systems, they never even have to think about this. But for a hybrid, it is a constant split-second requirement.
Which brings us to Section 3, Anti-Islanding Safety. And we are talking about a potentially fatal risk here. Picture this scenario. The local grid goes down. Maybe a street transformer pops. If your hybrid inverter just kept happily exporting your rooftop solar power back onto those local utility wires, it creates a condition called unintentional islanding. Basically, it keeps that dead street line live. The absolute danger here is that it could lethally electrocute a repair technician who's working on the lines, naturally assuming the power is cut. That's exactly why anti-islanding protection is built in. It forces the inverter to instantly disconnect from the grid the very millisecond it detects a drop in grid power. And that crucial, life-saving disconnect brings us right into our fourth function: backup operations and safe isolation.
Because of the risk we just talked about, the inverter drops its connection to the grid immediately. But stopping export doesn't mean your house has to suddenly go dark. To protect the utility workers, the inverter safely isolates your home from the dead grid. Sure, but it keeps a dedicated backup output active. This lets it feed your essential protected loads, like your fridge and your lights, using a totally isolated loop of solar or battery power. It essentially splits its own personality, keeping your house powered on the inside while keeping the outside world completely safe.
Finally, we've reached Section 5, Continuous Intelligence.
the millisecond manager. Let's take a look at how this machine synthesizes all these critical functions continuously, completely behind the scenes, without you ever noticing the heavy lifting. The inverter automatically cycles through different operating modes. It's using solar when the sun is shining, it's charging the battery with your surplus, it's drawing from the grid when batteries run low or the sun sets, and it's instantly flipping into backup mode if the grid fails. It measures, analyzes, and controls the entire ecosystem to optimize your home's efficiency, 24/7. To pull off this crazy balancing act safely, it's literally 5 distinct technological modules crammed into a single chassis. Under the hood, yes, you've got standard modules like the MPPT controller and the battery charger, but you've also got the real hybrid differentiators, the automatic control unit, and the network synchronizer. It takes an incredible amount of silicon processing power to coordinate all these hardware pieces so flawlessly.
So, to summarize our teardown, a direct comparison really highlights the difference. An off-grid system is basically just a power converter. But a hybrid, it's a parallel operating safety hub. It demands bidirectional energy flow, frequency tracking, phase matching, anti-islanding, and backup switching. The off-grid system simply doesn't have the processing brains or the hardware muscle to execute those massive grid-tied demands.
The big reality we need to take away from this explainer is perfectly summed up right here. A hybrid inverter is not just a power converter. It is a millisecond energy broker. It has to be this highly synchronized, grid-connected energy manager, but then, in a fraction of a second, be able to flip a switch and act as a totally isolated, independent power plant on demand.
Honestly, once you realize the sheer amount of intense processing happening inside that metal box, it completely changes how you look at your home's energy. And it leaves you wondering just how much other invisible engineering is out there, constantly working in the background, making microsecond decisions to keep our modern lives running safely and efficiently.